In this video we're going to be looking at the effects of y equals x plus a all squared plus b. What this is going to do is combine the last two videos of ideas, the first one being where y equals x squared plus b, and we discovered that if b was greater than 0 the graph moves up b places, and if b was less than 0 the graph moves down b places. I'm going to combine that idea with the one from the last video where we had y equals x plus a all squared, and we discovered that in these examples, if a was greater than 0 the graph moves a places to the left, and if a is less than 0 then it moves a places to the right. Okay, now I've begun as usual by plotting the graph of y equals x squared, and we can start being a bit more clever about where we want to plot these and what we want to put in this table here if we want to work out our exact values of our coordinates. Now, because we know from the previous video that x plus 3 moves the graph 3 places to the left, and we know that this graph moves up 1 place because it's a positive x, we can start thinking carefully. Now, we're always interested in the line of symmetry. In most graphs that or in the x squared graph that we've seen before, we're looking at 0, 0. In this case, we're going to be expecting our turning point to be at -3 because it's moved 3 places to the left. So our turning point normally is here. We're expecting our graph to be over in this direction somewhere. So what I'm going to do is I'm going to centre -3. Let's do -4 and -5. And let's do -2, -1, and we'll do 0 just for argument's sake, okay? So if we put -3 in here, -3 plus 3 is 0, squared is still 0, plus 1 is going to be 1. Doing the same either side of this, we'll end up with 2 and 2. And ending up either side here, we're going to have 5 and 5. And then this one here should be 10, because 0 plus 3 all squared is 9, plus 1 is 10. Okay? I'll just plot all these points again. So our turning point was going to be -3, 1. -3, 1 is there. And you can see it's moved 3 places to the left and 1 place up. That's what we were expecting. And sure enough, our next 2 points, and -5, 5, be there. And we've got -1, 5 would be there. And they've got 0, 10s up here somewhere. Okay. And if we know that this would have been over here, if we know that it was -6. So just following the lines of symmetry there. So, plotting our graph again. I mean, x is on the graph at the moment. This is where it becomes a little bit trickier because we're starting to overlap with each other here. Okay, so we can see it's moved, each of these places here have moved 3 along and 1 up. And that's pretty much it. Now, we're not seeing any negative ones for a little while, so I thought what we'll do is, for the next one, just have y equals negative x plus 1 all squared plus 2. That'll do. Just making up any old numbers. I can all see how they work out. I'm sure that you guys could do the same thing. Okay, so we've got x and y. And what we're going to do this time is, because we know that the +1 will move it 1 place to the left again, we're expecting our turning point to be somewhere in line with this -1 here. So we'll put -1 in the middle of our table, -2, -3, -4, and then 0, 1, 2. Yeah, that'll do. So putting this in here, -1 plus 1 is 0, still 0, plus 2. Putting 0 in here, 0 plus 1 is 1, squared is still 1, -1 plus 2 is 1, -2 follows the same pattern. 1 plus 1 is 2, squared, -4 plus 2 is -2, -2. 3 squared is 9, -9 plus 2 is -7. that will also be minus 7 there. So plotting those same points on there again and again, we can see our turning point is going to be minus 1, 2. Minus 1, 2 is there. We've got minus 2, 1 and 0, 1. No, I've just done that wrong. Hang on. See, even I make mistakes with this as well. Please excuse the rubber. So minus 2, 1. See, this is what happens when I don't pay attention to what I'm doing. But this is why I'm doing the graphs in pencil. Even I make errors with this. So minus 1, 2, my apologies, should actually be there. Minus 2, 1 would be there, and 0, 1 is there. Minus 3, minus 2, and 1, minus 2. And minus 4, minus 7, and 2, minus 7 would fall there. And we see that it's negative. We've still got our sad face, which is what we saw in the very first lesson. That sad face being formed there. And we've still got a turning point at negative 1, 2. And all that's going to happen is we end up with our curve looking something like that. Obviously you can extend it out in both directions from there. Now the shortcut for this, we saw that our turning point in this one is negative 1, 2. We notice that we've got a positive 1 and a positive 2 in here. What we can do with this, we can say our turning point, negative 1, 2. If we had the form x plus a all squared plus b, we can say our turning point for this one must be negative a, b. What we mean is the a changes the sign in front of it. If it's positive, it becomes negative, and if it was negative, it becomes positive, and b stays the same. And just to prove that this happens for this one, well, our turning point, we're expecting the turning point for this one to be negative 3, 1, and we can see clearly negative 3, 1 is the point that appears, and it's our source of, or our center line for our line of symmetry in the graph. Okay? So what we've learnt from here is that so long as we know what the equation is, we can work out our turning point immediately, and then from there we should be able to expand the rest of our graph and build it up accordingly. What I would suggest we do next is make sure that we're able to follow all of the examples that are appearing on the PowerPoint next. Thank you.